Hello grade 9s, this is Mr. Miller and welcome to lesson 8.2 on solving equations in the form ax plus b equals c, x over a plus b equals c. So just keep in mind that a, b, and c are just numbers. The only variable still is the single variable x. Notice that it's in one location in the equation, which means we can use the method of inverses to solve. But in number 1, we are asked to solve each equation. We're asked to use each of the following methods once. So an algebraic method once, using a diagram once, and using some concrete materials. So let's take a look to see if we can do that. Just zoom in on the first one. Okay, so here we have the equation 2x plus a quarter equals a half. And here's how I've chosen to represent it. So first stage, I'm going to represent it as a balance, a scale, where we have two unknown weights plus a quarter pound or kilogram. It doesn't really matter how you want to take it exactly. Being equivalent, balanced with 1/2. So what can you do to solve this equation? Notice here I'm using some concrete materials to solve this equation. Well, it looks like in addition to the half weight, we also have a quarter weight. So why don't we just replace the 1/2 weight with two 1/4 weights? And that way it's pretty easy to see that if we just, in step 3, remove a quarter weight from each of the trays, that will maintain that balance. So from here, if this is two x's, two unknown weights, we want to know what is the one unknown weight x, then all we'd have to do is just take half of this, right? And half of that, well, we'd need to replace that 1/4 weight with some 1/8 weights, if we had such a thing. And then we could split it up into two equal parts, so each 1x would be 1/8. So that's how you can solve with some concrete materials. X equals 1/8 is the solution for this equation. So now the next one, part B, doesn't really lend itself to doing that so much. So instead what I'm going to use is an algebraic method for this one. You can see that there's one variable in one location in the equation, so I can use the method of inverses. Here we're dividing by 2.5 and adding 1.5. So to solve, we can subtract 1.5 from both sides. We end up with m over 2.5 equals negative 0.7, and then multiply both sides by 2.5 to get m equals negative 1.75. And that's the solution for that one. Now let's take a look at part C. And in part C, we're going to use some algebra tiles. So this is, we've done our algebraic method, we've used concrete materials. This is a diagram. So my diagram, I'm choosing to use algebra tiles. Very easy to do 4x plus 1 equals 9. It also lends itself well to this because we have all integer numbers here. So here are 4 x tiles and there's a 1 tile. And we have a little separator, a dotted line for the equals. And then here are 9 1 tiles. If you don't have the colors, you can just make sure that these things are shaded in to indicate that they're positive. So now to solve this, the first thing that we're going to do is we're going to add a negative 1 tile to both sides. The reason for that is because the plus 1 and minus 1 will cancel each other out and we'll be left with just the 4x on the one side, and on the other side there's going to be one cancellation of a tile here, and there's going to be 8 1 tiles left. From here you can see that we have some nice, we can do some nice grouping. We've got 4 groups. So all we have to do is divide by 4, and we get that each single x is equal to 2. That's the solution for the equation. So now from here, number 2, we want to solve each equation, and for part A, we want to check our answer. So looking at equation 2A, we have 2 3/4 equals 3m plus a half. You can see that there's only one variable m. It's only in one location in the equation, so we can use the method of inverses. So ask yourself, what is being done to m here? We're multiplying it by 3 and we're adding a half. So to solve, we start off by subtracting a half from both sides. Now in order to subtract the half, on the left we have to take the 2 3/4. Might be handy to write it as an improper fraction, 11/4. We want to subtract 2/4, so getting that common denominator of 4, 1/2 is equal to 2/4 because you're multiplying the top and the bottom by 2. And a half minus a half, of course, that's gone from the right hand side. So now the 11/4 minus 2/4 leaves you with 9/4. And now we've subtracted a half from both sides. The other thing we need to do is we need to divide both sides by 3. So dividing both sides by 3, you end up with m equals 9/4. In order to do divided by 3, we multiply by 1/3. We multiply by the reciprocal. And there's a factor of 3 that divides out between the 9 and the 3. And the answer ends up being 3/4. Now, what we'd like to do next is a check. So in order to do a check, we copy the original left-hand side and right-hand side of the equation down. The next thing we do is we replace the variable m with what we think is the solution. Now we need to calculate. So 3 times 3/4 is 9/4. And if you're going to add a half to it, you have to change it into 2/4. And that is equal to 11/4. So does that match up 2 3/4? Well, if we take 2 3/4 and we change it into an improper fraction, 2 times 4 is 8 plus 3, and it is 11/4. Same thing. So since the left-hand side and the right-hand side are matching when m is equal to 3/4, we know this is a valid solution. Now we can go on to part B. Here we have x in one location in the equation, and it's the only variable. So we could use the method of inverses, but I would suggest maybe first let's try this. We're going to look at the denominators 2, 3, and 6 and figure out what is the least common multiple. So 2, 4, 6, 8, 10 multiples of 2, 3, 6, 9, 12 multiples of 3, and 6, 12, 18 multiples of 6. And you'll notice that the least common multiple is 6. So we're going to multiply both sides of the equation by 6, which means we have to use the distributive property on the left. So we're going to do 6 times the first term plus we're going to do 6 times the second term. You notice that I've written the 6 as 6/1 because we're doing multiplication of fractions here. Now there's a factor of 2 that divides out between these two, and we're left with 3x. There's a factor of 3 that divides out here, and you're left with just plus 2. The 6 divides out here, and we're just left with 7 on the right-hand side of the equation. So by multiplying by the least common multiple of these three denominators, we ended up with an equation which no longer has any fractions in it. And it's kind of easier to deal with. Now again, you ask yourself, what are we doing to the variable? We're multiplying by 3, we're adding 2. So we're going to subtract 2 first, then divide by 3 to solve. So subtracting 2 from both sides, you get 3x equals 5. Dividing both sides by 3, you get x equals 5/3, which is equivalent to 1 2/3 if you want to have it as a mixed fraction, or 1.6 repeated if you want to have it as decimal. So now moving on to part C. So here we have a single variable n. It's in a single location in the equation. Method of inverses applies. So we're dividing it by -0.6. We're adding 0.23. So first off, we're going to subtract 0.23 from both sides. We get n over -0.6 equals 1.7. And now we multiply both sides by -0.6, which gives us n equals -1.02. And moving on to part D now. We have a single variable x in a single location. What are we doing to x? We're dividing it by 1.4 and we're adding 3.4 to that. So first thing we do is subtract 3.4 from both sides. We get x over 1.4 equals 1.1. Now we multiply both sides by 1.4, And that leaves you with x equals 1.54. And now we're on to part E, because I like to party. You can see, again, we've got a single variable c located in a single location in the equation, multiplying by 4, adding 2/3. So, subtract 2/3 from both sides. Notice that I already changed it, the 2/3 into 4/6, because that matches the denominator here, making the work a little easier. So we get 4c equals negative 5/6. Now dividing both sides by 4, we get c equals negative 5/6 times 1/4. Dividing by 4 is like multiplying by a quarter, multiplying by the reciprocal with division of fractions. And you get c equals negative 5/24. And finally, part F. Let's see, we have negative 9.2 equals 0.2x plus 2.4. Could use the method of inverses here. So I chose to multiply both sides by 10 first so that I can clear the decimals. So I get negative 92 on the left. I need to do the distributive law on the right. So 10 times the 0.2x gives me 2x. 10 times 2.4 gives me 24. So now we have an equation that no longer has decimals in it. So again, you ask yourself, what are we doing to x? We're doubling it, adding 24. So subtract 24 from both sides and divide both sides by 2 to get x equals negative 58. Okay, so now we are on to problem solving. Question number 3, it says create an equation for each of the following, solve, then check. So the first one says when a number is tripled, then increased by 13, the result is 82. Find the number. So the first thing you want to do when solving a problem using an equation is to declare what your variable is going to represent. For instance, let n be the number to be found. Now you need to make an equation. It says when a number is tripled, then increased by 13, the result is 82. Translated into algebra, looks like this. The number is tripled, it's increased by 13, and the result is 82. So now we've declared the variable, we've set our equation, we just need to solve the equation. So subtracting 13 from both sides, we get 3n equals 69. Dividing both sides by 3, we get n equals 23. And now we just need to answer the question. So go back and reread just to make sure we're getting it right. Number is tripled, increased by 13, the result is 82. Find the number. Okay, so the number is 23. Now on to part B. And in part B it says that Jane spent $42 for shoes. This was 14 less than twice what she spent for a blouse. How much was the blouse? So you can declare your variable to be B, the price of the blouse, and then make an equation from that. So it's 42 is 14 less than, so subtracting 14 from twice what she spent for the blouse. That would be 2b. Now we just have to solve the equation. Adding 14 to both sides, dividing both sides by 2, we get b equals 28. Now go back and reread the question and make sure that you know what you're going to give as your final answer. So Jane spent $42 for shoes, 14 less than twice what she spent for a blouse. How much was the blouse? Aha! The blouse was $28. And last word problem. Says the sum of two consecutive numbers is 37. What are the numbers? So consecutive numbers are numbers like 1 and 2, 2 and 3, 7 and 8, 100 and 101. So you can let n be the first number, and so n and n plus 1 are consecutive. So now it says that the sum of two consecutive numbers is 37. So the sum of these two would be n plus 1. And that's supposed to add to 37. Now solving the equation, we have to collect like terms on the left first. So that gives you 2n plus 1 equals 37. Now you see we're doubling n and we're adding 1, so subtract 1 from both sides, then divide both sides by 2, and we end up with n equals 18. Go back and make sure we're answering the question properly. What are the numbers? So both of them. So therefore the numbers are 18 and, that's n plus 1 is the other one, 19. And just to check, 18 plus 19 is 37. That's what it's supposed to add to 37. So there you go. That concludes this lesson. Thanks for watching and have yourselves a wonderful day and a great March break. Bye-bye.